once again I welcome you all to another learning journey in our assessment and learning too. But before anything else, by the way, I am your teacher Anna saying, learning is fun, so come let's learn together. Last time, we've done already defining what is assessment, analyzing the fundamental concept and characteristic of the 21st century assessment, applying principle in constructing and interpreting performance-based assessment, developing instrument for effective learning, and portfolio assessment, specifying the types of assessment, sample products, scoring rubrics, and rating forms. And today, what we're going to discuss is about statistics and computer tools for analyzing of assessment of data. This covers the basic concept of statistic, relevant statistical treatment that can facilitate the interpretation and analysis of the data, and the usage of computer as an aid in analyzing and data presentation. Just hearing the word statistics, I know it conjures images causing anxiety. Even those educators who do not consider themselves numerically deficient, statistics intimidates them. As a future educator, there is a need for us to know how to use tools for analyzing of assessment data like the statistics and computer effectively, because it will enable us to process data and give results or reports and interpret learners' performance more clearly and more effectively. Now, let's define first what is statistics. According to Brace and Brace 2012, they define statistics as the study of how to collect, organize, analyze, and interpret numerical information from data. Statistical techniques helps teachers too. First, analyze and describe results of the measurement obtained in their own classroom. Understand the statistics used in test manuals and research reports, and interpret the various types of derived scores used in assessment. We have two types of statistics. These are the descriptive statistics and the inferential statistics. Let's define and differ descriptive and inferential statistics. Descriptive statistics. Descriptive statistics is used to describe a group of individual or describe the data that had been collected, to describe variables that were grouped in order to determine the measure of certain dependent variables that needs to be measured. Indices calculated using sample drawn from population is called statistics, while indices calculated using the entire population is called parameters. On the other hand, inferential statistics is used when there is a need to make a decision, estimate prediction, or generalize about the population based on sample. We have two types of tests in inferential statistics. These are the parametric test and the non-parametric test. Parametric test is a test significance used if the data represent an interval or ratio scale of measurement and the other assumptions have been met, while non-parametric test is used when data represent an ordinal or nominal scale, when parametric assumption has been greatly violated, or when the nature of the distribution is not known. So therefore, descriptive statistics is a type of statistics used for summarizing and describing data sets, while inferential statistics is used when there is a need to make a decision, estimate predictions, or generalize about the population based on a sample. Let's move to statistical tools. We have three types of statistical measures. These are the measure of central tendency, the measure of variation, and the measure of relationship. But what do you mean first by statistical tools? When we say statistical tool, it is a set of techniques that allow the process of improvement and the reduction of error for troubleshooting. When carry out meaningful comparison among sets of test scores, a statistical tool is needed. Let's proceed to the first measure of a statistical tool, which is the measure of central tendency. Measure of central tendency has three types: the mean, median, mode. Now, let's define each of them. The mean. Mean is an arithmetic average of all scores in the distribution. It is most frequently used index of distribution in central tendency. It is computed using every scores in the distribution, and its strength is also its weaknesses because several typical high or typical low scores, sometimes called liars, can distort the value of the mean. The median. Median is the point that divides the scores into two equal halves. It is the second most frequently used index of central tendency. One advantage of median as a measure of central tendency is that it is not unduly affected by peculiarly large or small scores. The median strength is also its weaknesses. The median fails to reflect the magnitude of the impact of every scores in the distribution, even when a certain of those scores are very high or very low. The mode. Mode is most frequently occurring scores in the distribution. In some cases, a distribution has two or even three most frequently occurring scores. In such cases, a statistician refers to it as a bimodal or trimodal distribution. We also have multimodal distribution, referring to those with three or more frequently occurring scores. Below are Amara's subject and the corresponding grade she got for the previous grading period. Compute for the mean, median, and mode. Subject taken were Filipino, English, Mathematics, Science, Social Studies, TLE, and MAPE, with the following grades of 91, 87, 90, 88, 87, 89, 87. To compute the mean, all you have to do is to sum up all the values and divide it by the number of values. Solution as follows. While in getting the median, all you have to do is arrange the number from least to greatest, then locate the middle number. And for the mode, all you have to do is to locate the frequently occurring scores in the distribution. Aside from describing how sets of scores tend to the center of the distribution, the information about how variables scored are is also important. It is also relevant to know how to spread out the scores are. To know this, we have measures of variability: the range, quartile deviation, and the standard deviation. The range. Range is calculated by subtracting the highest score to lowest score. It is a readily calculated index of distribution's variability. If there is an abnormal highest or lowest score, the resulting range will yield a misleading indication of the distribution's overall variability. The quartile deviation, also called semi-interquartile range. It is based on the range of the middle 50% of the scores instead of the range of the entire set. It indicates the distance that is necessary to go above and below the median to include approximately the middle 50% of the scores. The standard deviation. Standard deviation tells the average distance from the mean for each of the scores in the distribution. The more spread out the scores are, the larger the value of the standard deviation. The less spread out the scores, the smaller the standard deviation. Aside from the measure of central tendency and measure of variability, here is another group of standard score that we can be used in assessment. These are the z-scores, t-scores, the Stanines, and the percentile rank. Z-score. Z-score expresses test performance simply and directly as the number of standard deviation unit a row score is above or below the mean. A z-score is always negative when the row score is smaller than the mean. Thus, z-score is seldom used directly in test norm, but are transformed into standard score system that uses only positive numbers. T-scores. T-scores refers to any sets of normally distributed standard scores that has a mean of 50. This formula is true only when the original distribution of row score is normal. The reason that T-scores is prepared to Z-scores for reporting test result is that only positive integers are produced. The Stanine. The Stanine system uses a 9-point scale in which 9 is high, 1 is low, and 5 is average. Stanines are normalized standard scores that make it possible to compare students' performance on various assessments. It uses a single-digit score, it is easily recorded, and takes up less space than other scores. The percentile rank. Percentile rank is one of the most widely used and easily understood method of describing assessment performance. It indicates the student's relative position in a group in terms of percentage of the students scoring lower. Note: standard score has also shortcomings. Each shortcomings include students and the parent find it difficult to understand, and the interpretation of it is difficult unless the scores are evenly distributed. We have kind of indicators of relationship in describing the relationship of scores in different subject areas. These are the graphic presentation, the product moment correlation, and the rank order correlation coefficient. So let's define each one of them. Graphic presentation. By using graphic display techniques, the relationship between variables can be described according to its magnitude if it is strong or weak, and its direction if it is positive or negative. The product moment correlation coefficient, popularly known as Pearson correlation coefficient, named after the English statistician Karl Pearson. It is most widely used indicators or the magnitude and direction of the relationship between two variables. The rank order correlation coefficient, also known as Spearman's correlation coefficient, which was introduced by Sir Charles Spearman. It is interpreted in essentially that the same way as Pearson's product moment, but simpler to compute. It is another technique estimating the magnitude and direction of the relationship between two variables. It uses data represent only an ordinal scale and not necessarily an interval. Interval scales allows you to believe that there are equal intervals that are in distant point of the scale, while ratio scale is an interval scale for which 0 point exists. On the other hand, ordinal scale is based on rank. In the previous discussion, fundamental concepts of statistics and statistical tools used for different statistical methods were discussed. Now, let's explore simple computation of statistical treatment with emphasis on the usage of computer and software such as MS Excel. MS Excel is a software developed by Microsoft to make computation more efficient and less prone to error. Computer, aid in statistical computing and data presentation. Here is the basic step in opening the MS Excel program. So first, click the icon of your Microsoft Excel. This is the initial window that will appear if you are using the latest version of Microsoft Excel. Simply click on the blank document option. Now, once the worksheet had been opened, it is now ready for data entry. You may now encode the scores or data that you want to be processed. The worksheet is like this. Now, you may start encoding your data as we will start discussing about charts and frequency distribution. Charts and frequency distribution. Using the encoded data, it can be converted into charts and diagram. Note, there are many different types of chart depending on the user's preference. It could be bar graph, pie chart, line graph, and etc. And just some of the charts are available in this software. Computing for measures of central tendency, variability, and correlation. Statistical functions are available in MS Excel. Click the Formulas tab and the different available formula logically organized will be displayed. Choose the More function icon, then choose Statistical. Several statistical formulae are provided in the list. For the mean, the function average will be used. That concludes my discussion about the measure of central tendency, measure of variability, standard scores, indicator of relationship, computer statistics, and data presentation. That's all for today. Once again, I am your teacher Enna saying thank you and God bless. Bye-bye.